All right, so this is 121, Computer Forensics, and you're at the second class now. So on my page here, samsclass.info, which I'll put in the chat in case anybody doesn't know about this page. This is the main page where I keep everything, although you could probably work from the canvas pretty much also. Although the canvas just points back to this page. This will be my main page because the canvas is under the control of the college and it comes and goes. And I use these projects for workshops at DEF CON and all over the place, so I need to have them available to me outside the control of the college. Anyway, so on this page are the videos from the first class here. And we're now up to the second class, Module 2. And so that's what I'm going to go into. If there are any questions, put them in the chat up here. I see a few morning greetings up there in Twitch. And if anybody has come to add, just make an add request in the City College online system, and I will approve them all. And by the way, I had a student completing an incomplete from a previous semester, so that meant the City College system could not handle that, which is why I avoid using City College services as much as possible because they just don't work very well. And so I had to make a server for non-City College students, so now this class is available to anybody. Even if you're not enrolled at CCSF, I've made a copy of the canvas over here. And so I will, you'll be able to participate in the course and do everything, but you won't earn official college credit. But that has been popular in the past. People in other countries and in other cities, other states that don't have classes like this sometimes would like to participate, so you can. That is true of all my courses now. This was the one exception. Since I was first developing this course, I haven't taught it in years, I thought I would just keep it to City College students only, but that proved to be impossible, so I just opened it to the whole world. All right. Anyway, let's take a look at the Module 2, which is at the City College canvas here. Yeah, it turned out to be pretty easy to open these things to the whole world. I started doing it a few years ago, once again after the administration fouled up, and it turned out to be a good thing. Yeah. Whoa, nothing here. Well, all right, let's see. What have I done wrong? Okay, go back. Home. Oh, I see. Computer Forensics, go to Modules. Okay, I'm going to get there. Yes. Yes, my computer is not responding. Modules, I say. There we are. Modules. Now maybe I can do Student View. Well, all right. I'm beginning to have my doubts about the City College Canvas server right now. Let's try going to the correct module first, which would be Module 2. All right, this is what I'm hoping to get to, this Module 2, Lecture 2. All right, and now I'm hoping that's available in Student View. And it is. Well, good, then I feel better. All right, so understanding the operating system is really important. If you're going to do forensics, it's really a lot of what you do. Another part is communicating and writing clear reports. But anyway, so this is the main thing a forensic examiner is an expert in, is technically how the operating system works, how data is stored on a hard drive, how it's sent over networks, and so on. So you understand how to read the binary raw data and interpret it and understand what it means. It means that this person saved a file, this person downloaded a file, and so on. So we're going to talk about the Microsoft operating system here, which is the most common and most important one, although I think we'll cover Linux later. So on a hard drive, which is what most people were using, although now more and more of them are using SSDs, although they work somewhat similarly, the hard drive has these tracks that go around the drive in circles, and the tracks are broken up into sectors and clusters. The sector is 512 bytes, and the read-write head can only read and write 512 bytes at a time. You cannot write just 1 byte to the disk. If you want to write 1 byte to the disk, it writes that 1 byte, and then another 511 other bytes to do a write of 512 bytes total. This is important. as I'll explain here. Now, there's three kinds of data on a disk. There's two kinds. There's active files and slack space. And so what happens is a file that's in current use has a name in the directory and an owner and a creation time and metadata. And so there's a directory someplace, usually out here in the master file table. And then it will tell you the data is stored, say, on this blue track here in these clusters. So it's stored in 512 byte sectors, and typically, in order to make it faster to index, it groups those into clusters. And on most modern disks, the sectors are always 512 bytes, and the clusters are typically 4 kilobytes. So that is 16 sectors, or maybe it's 8 sectors. 8 sectors. So your file is written as a series of clusters out here, and the index has them, and that's a file that is currently in use. Now, when you delete a file, it just changes the directory entry to say this file is no longer in use, and it does not erase the file contents. Those are called unallocated storage spaces. The data is still on the disk, but it's no longer in the index, and so at some time in the future when you save another file, it might be saved on top of that. This is why the fundamental thing that is known to forensic examiners and not to most users is that when you delete a file, that file is not erased. That file is merely rendered available for future use. And what this means to forensic examiners is when you examine a disk, you will often find files that have been erased, and they're often the most important files because the criminal often deletes files to try to hide the evidence. Now, there are ways to completely wipe a file, a forensic wipe. One thing is to download a tool called Erasure. Another one is to download a tool called steganography. These files help you clean all the sectors that are no longer in use. And if you use those tools, then when you delete a file, it not only removes the metadata from the master file table, which is the file name and the location and the owner, it also erases all the clusters. And if you use that tool, you cannot recover the deleted files. And about half of the SSDs in use have automatic garbage collection, so in fact they do automatically delete these clusters in most cases, although not always. But about half of them don't have that working correctly, so that in fact they do preserve data like hard drives. So this is also related to computer forensics, is the job of data recovery, where you're just trying to get data that people have lost by accident. And on magnetic drives, you can very often recover a large amount of data that was erased. On SSDs, it's kind of hit or miss, but sometimes you still can. So anyway, by the way, there are bad sectors on disks too. Those are sectors that have some kind of defect so that when you store data and read it, it doesn't come back perfect. Some of the bits are broken. Now, what happens in that case is even more interesting. The hard drive will, these days, modern hard drives will silently replace that sector with an extra sector. So if you buy a 1 terabyte hard drive, it will have a little extra space that it doesn't tell you about, and the drive controller will just silently replace the bad sectors with good sectors from the extra space, so your operating system will continue to run as if that sector was working. But what it means is there is some data on that sector, although partly corrupt, that cannot be located, read, or erased by the default firmware. So you cannot erase that drive. This is why, one of the many reasons why, if you want to decommission a computer and donate it to somebody, the best thing to do is physically destroy the hard drive. There is no way to really be sure you've erased all the data. Anyway, so we talked about this. So if you were to store an 800 byte file on the disk, it would fill a 512 byte cluster and part of another. And then what would happen is there would be leftover space in that next cluster. So there are various kinds of leftover data here. From files that have been deleted, there are whole clusters full of old data out here, enough that you could perhaps reconstruct a whole file. But also there's overhang. If you filled one sector and part of the next sector, there would be a few bytes left at the end, up to 512, in this sector left over from a previous file. So you might find fragments there, like a few words from a Word document or something. Usually that's such a small amount of data it's no use, but in principle there can be little bits of data left in there. All right, so here's the mechanical structure of rotating hard drives, which I don't think is all that important. You got a read-write head and so on, typically a series of platters. All right. Now, the operating system uses virtual memory. In the old days of, say, MS-DOS, you would open a program, and if there was not enough RAM, the program would just stop and say, you have to improve your computer, or you can't run this program. But modern operating systems are not willing to have that kind of limitation. So if you have 4 gigabytes of memory in your computer, and you open an application and another until you've used up all the available memory, you can keep on opening more applications, and what it will do is take some of the data that's in RAM and copy it to the hard drive in a temporary file called a page file, and free up some RAM. So you can use more than 4 gigs of active memory. It will be slower, of course, because the hard drive is 1,000 times slower than RAM. So there'll be a delay at some point when you try to open some program that should be in RAM, and there's a page fault, is what happens in the operating system when it looks for the data in RAM, and it says, no, that data has been swapped to the hard drive, and I have to swap some data to put that data back in RAM. So there will be a delay while it loads that data in RAM. But anyway, that's the page file, and therefore the page file on a system contains some fragments of memory from RAM. So that's interesting. You can find some data in there, although like other RAM evidence, it's limited. RAM data does not contain creation dates or owners. So when you find something in RAM, you don't really know who put it there or where it came from. When I took one of my best forensic courses, a forensic teacher came to City College and taught it in our hacking lab. We had just replaced all the computers in there. And when we got to this section, we ran a RAM image of those machines, and in the RAM image of one of those machines, I found an email that I had written to my sister 2 years before on the previous generation of computers that had been removed from that room. What apparently happened was, I was working in the lab, I sent my email, and then apparently the technician used that machine as the template to make the ghost image, to put an operating system on the new computers, and it included that data. And my forensic teacher said, yes, make a note of this. That's the problem with RAM data. You don't know where it came from. It could have come from years ago, from something else. In that case, even from a different hardware. So just because you find something in RAM doesn't mean you can say, this perp put that thing in RAM. You need more evidence for that. So anyway, all right. Now, binary, decimal, and hexadecimal. You've got the binary games you're hopefully doing here, and I'll have a Kahoot to get people moving on that later if you haven't. So you get used to reading these things. And there are various kinds of file types. File headers are really important. So hexadecimal to ASCII tables. Let's see if we have a good one here. Yeah, we do. So here's a list of characters. These are funny control characters, not used that much, like backspace and inquiry. Down here, you have the printable characters. So you have space, an exclamation point, and now you have the numbers, 0, 1, 2, 3 to 9, and then A, B, C, D, E, F, and all that. So every printable English character, every character you can type, has a binary form. A is this. This is 65 in base 10. And so 65 stands for capital A and 66 stands for capital B, and so on. So you get used to reading this and understanding it, and you get used to reading it in hexadecimal. And now you can see this JPEGs, for example, have a file header including this string, JFIF. At the start of almost every file, there is a file header which gives you some information, including the type of file it is. So one of the main skills of forensic examiners is to look at a raw hex dump and recognize common file types, because you'll be looking at data on a hard drive, and you often have to spot when something is a file. So some of the most common important ones are JPEGs start with JFIF, those are web images. PDF files, Adobe PDF starts with PDF near the front, and zip start with PK, because the zip format was long ago invented by Phil Katz, and he started all the zip files at PK. And you'll see a few of these in the hands-on project I'll show you later. All right, so when you boot your machine, you turn on the power, it loads the code from ROM, and it boots up, and then it loads an operating system from the hard drive, or in principle a floppy, although these days almost always a hard drive. Now the kernel is the core of the operating system that must always be in RAM, and it's the only part of the operating system with full privileges to use all the processor's instructions and therefore control the hardware. If your program, which runs in user land, not kernel land, wants to say, put something on the screen, it cannot directly access the hardware. It has to ask a kernel routine to please do that for me, because that's considered too dangerous for an average user to write code like that. You only trust Microsoft to write the kernel, and all your programs work by making API calls to the kernel to ask the Microsoft code to please put that character on the screen, and so on for you. And we go through that in great detail in the malware analysis class. So your process boots up, running small pieces of code to load up next pieces. These days, it uses UEFI instead of BIOS, which is just a way of storing system settings during the boot up process. So your computer finds out where the operating system is and how many devices are connected and how much RAM it has and things like that. All right. So the master boot record is the first sector on a hard disk, and this includes information about the other partitions on the hard drive and how to find them. And it depends. There are various ways to lay out a hard drive, but the MBR system, you can only have 4 partitions on a disk, and the partitions are mounted by Windows with different drive letters typically. So the Windows then has a file system, which is how it stores files, and it keeps track of the name and the owner and the creation date and so on. There was an old system called File Allocation Table that was used by MS-DOS and Windows 95 and Windows 98. But long ago, decades ago, Microsoft made a new system that is much better called NTFS, and almost everything now uses NTFS. The only thing that uses FAT anymore is removable USB sticks. And in principle, those floppies, if anybody's still using those. Little portable devices, but hard drives are all NTFS these days. NTFS is extremely old, dating back to '93, although it had minor version upgrades. Microsoft has been promising a new one for years, but they never really came out with it. So NTFS is what's used by all modern versions of Windows. All right, and NTFS has all kinds of useful features. The most important for us is probably access control lists. NTFS let you specify who's allowed to read this file, and it also has an owner, which is another part of it. FAT files did not even have an owner. Just access to the drive meant you could read the files on it, which is what you want for a portable thing like USB stick. But important for forensic examiners, now every time a file is created with NTFS, it has an owner recorded with it and a creation date. So you can tell who put it there and when they put it there. All right. So NTFS has a USN, update sequence number, that keeps track of the time when things were changed. It keeps a journal. This is because there was a huge problem with Windows 98 and other FAT-based systems. If you were working on your computer and you started saving a file, and then the computer crashed or the power went out during that, it would end up in a state with part of the file saved on the disk, and it would have forgotten what it was doing. So when you boot up the machine again, there would be a long process of recovering lost clusters. It would find data sitting on the disk without knowing what it was, so it would gather that data, put it in a file in the root of the hard drive called file 00001, 0002, and you'd have these fragments of files appearing there, and you would have lost some data. So to prevent that, all modern operating systems like NTFS and Linux's ext3 and later systems, and maybe even earlier ones, but certainly ext3, practice journaling. So if they're doing anything like I am saving a file, it makes a record. Okay, I'm saving this file. I'm writing the first block. I'm writing the second block. It keeps a journal of everything it does, so that if it crashes or the power goes out and it wakes up, it can look at the journal and say, what was I doing? Oh, I was doing this. Well, then I'll resume and finish doing that, instead of just having half-finished jobs making a mess of things. And so that's the journal here, and it stores a lot of information about what's been happening. Now, another feature, which is somewhat important for forensic examiners, is alternate data streams. Alternate data streams is something you don't hear very often. It's a Windows feature added for compatibility with Apple. Apple was big in music and movies before Microsoft was, because they focus on consumer and recreational stuff. So they would have albums where you could play the music, and then they would also want to have like cover art and liner notes associated with that song. So they would have multiple streams of data tied to the same file name. One file name would point to the music, or to the album notes, or to the cover art. So that's called an alternate data stream. So a file is like a folder. It can contain other things inside it. And that's a possibility in Windows too. And maybe a decade ago, this was important because malware could hide malware in the alternate data streams, and your antivirus products wouldn't find it there, although everybody's pretty much updated to handle that now. All right. And the master file table is the main directory of the NTFS file system. This is where it records all the file names, all the owners, all the access control lists, the dates, and so on. It's very important. So there are 2 copies of the master file table on the hard drive, because if one of them gets corrupted, you'd lose everything. So it has a second copy to prevent that. And it keeps track of bad clusters and many other things. Prefetch files are very handy for forensic examiners. Every time you run an application on a Windows machine, it adds a shortcut to the Prefetch Files folder, and the point of this is modern computers have a lot of memory, like 2 or 4 or 8 gigabytes, and you're usually not using all that. So what it does is it keeps track of the last 128 programs you've launched, and when you boot up a machine and then you just leave it sit there, or you're just reading a web page or something, you're not doing anything that uses much memory, so it starts loading those programs in RAM. Because it figures you used them recently, you're likely to use them again, so it automatically loads some of them in RAM so they'll load faster when you want them. And that's the prefetch folder. And for forensic examiners, this is wonderful because I have a record of the last 128 applications that have been run on this machine right there, easy to see. The only thing annoying about it is these prefetch files are in a strange format, so you have to use a special tool to extract them. But there are plenty of tools that can do it. And another thing annoying about it is that you will only find it on desktop versions of Windows, I mean consumer versions like Windows 10 and Windows 11. It's turned off by default on Windows Server operating systems like Server 12 and Server 16 and Server 19. Anyway, superfetch files are just there to increase performance, and I haven't seen much good out of them in forensic examination. Shell bags, however, are quite useful. If you open a window, like the My Computer window on a Windows machine, and then you close it, when you open it again, it will appear in the same location on the screen with the same view parameters. That's what shell bags do. They remember the physical appearance of every window you've opened. And that means they're a record of what you've opened and what you've seen. So one thing about them is you can see what people have been looking at. And I hope you're noticing the general feature here. Windows is not intending to spy on you. It's not designed by an oppressive government to record everything you do, but just in order to make it run better, it does keep a whole bunch of records of everything you do. So if you do anything on a computer and then you want to deny that you did it later, you've got a big problem because all these records are being kept accidentally of everything you do. And forensic examiners learn how to find those records to figure out what people have been doing on computers. The Shim Cache keeps a record of executed binaries and ones that have been viewed in Explorer but not executed. So that's another useful place to find information about what programs have been run or looked at. And then we get to the Windows Registry, but before we do that, I want to look at a Kahoot. So let me fit this to my window. I've got mod 2A here. That should do. There, this will do. And that. I'll give it a few more seconds. All right, I guess this is how many we're getting. Okay, which item is 512 bytes? Okay, that's a sector. Cluster is a group of sectors. Cluster is usually 4 kilobytes. I see the lag is pretty bad, so people playing Kahoots will have to just look at the Kahoot images that are sent directly to your computer. The Twitch will be lagging behind. All right, what's the first sector? Okay, that's the master boot record. The kernel is in RAM. It's not on the hard disk at all. Well, there is a file on the hard disk called NTOS kernel, but it's loaded into RAM. All right. All right, so what file system does Windows use? Yeah, that's NTFS, the new one. FAT was the old one, hasn't been used in decades. All right. All right, so what artifact records recently executed applications? The Prefetch Files list the 128 most recently executed programs, and who executed them and when. Very handy. I think they have the person who executed them. I guess I'm not really sure of that. We'll see it in the hands-on projects later. So, I know who S squared is, but Pencil will have to tell me who they are if they want their points. And DLR looks like good initials. My grader will probably be able to figure out who that is. All right. So, all right, let's go back to here. All right, so now we get to the Windows Registry, which I found pretty big and daunting and complicated when I first learned about it. But there are quite a few important artifacts in here for forensic examiners to know about. In the old days, like MS-DOS, Microsoft did the same thing that Linux still does. Every program would just have its own little text file somewhere, keeping track of its configuration. I see DLR giving me more information, which is good. Good. All right, anyway, so Microsoft decided in their wisdom to no longer do that, to have little text files scattered all over the place storing information about configuration, but to gather all that configuration data about the operating system and all the installed applications into a binary object called the registry, which is a database. And it is a very strange object. It's stored in like 11 or 12 files on your hard disk scattered around and gathered into objects called hives, which look like folders, but they are strange structures and they're not even independent. Some of them refer to little pieces of previous ones. So HKey classes root contains the association of file name extensions with programs, which does not exist on Linux. Microsoft invented this system where you put a 3 or 4 letter extension on a file, like exe or HTML, and then you define something called the default application to handle that file, and now when you double click on the file, it automatically launches that program. And this is the registry key that keeps track of that. The Word documents should open doc files, and Edge should open HTML files, and so on. HKey current user is in fact a pointer to part of the HKey users hive. HKey users keeps track of the information about the custom settings that every user on this machine has made. One machine can have many user accounts, and they can have different background images and start menu items and so on, and those are kept track in their ntuser.dat file in their user folder. But when the machine boots up, it doesn't know who the current user is. It has an HKey users hive, which takes track of all the users. When the user logs in, it learns which user is currently using the machine, and then it creates the HKey users hive, which points to one of these users. And that now points to the files that will contain the custom settings for that user. This we'll spend a lot of time looking at forensically, because it's where a lot of information about what the current user has been doing is stored. HKey local machine contains information about the hardware settings, and HKey current config contains the current hardware profile that's in use. In principle, Microsoft operating systems have the ability to have multiple hardware profiles because you could have a laptop that you dock at home in a docking station or you carry without a docking station, but most of the time there's only one hardware profile actually used. So these are called the keys, and they are called subkeys here. They look like folders and subfolders, but that's just an illusion. They're really a strange object in the hive. One of the many strange properties of the registry is you cannot have an empty folder. It always has to have some value, even if it's a default value not assigned. So it's really a database. It's not a group of nested folders. It just looks like that in regedit. And Microsoft added a lot of features to Windows in the various versions. Vista added defragmentation automatically, so you don't have to do it manually the way you used to, just to clean up the hard drive to make it run more efficiently. ReadyBoost was a misguided attempt to make machines run faster if they were very low on RAM by using a USB stick as temporary RAM, and it wasn't very popular. It didn't accomplish much, and it kind of didn't do any good. But the Volume Shadow Copy service is very important. This is a feature that came out with Windows 2000 Server, and what it is an automatic backup system for certain files. So this makes it possible to roll back your system to a previous time, and in modern versions of Windows, it makes extra copies of everything, every active file. So you can roll back to a previous version, and that's very useful to a forensic examiner. Examining the volume shadow copies is a way to see what used to be on the system, which is very important because the users will try to delete files and hide them, and you can often find the backup copies there. People say Vista is a joke. Yeah, well, I taught Vista, and then I immediately moved as fast as possible from Vista up to Windows 7, and so I was teaching a Windows 7 course with like a beta version of Windows 7, while the course still said Vista, and I had a student said, wait, I really need to get Vista certification because I'm in the U.S. Army, and the U.S. Army made Vista their standard operating system. And by the way, I got Vista certification too. That and $3 will get you a cup of coffee. But anyway, I'm certified in Windows Vista. Anyway, so Windows 7 was the upgrade from Vista, much more popular, and it had a lot of features like jump bars, where you can have these bars at the bottom of the window and they remember what you've been doing, which you still see on Windows 10. Let me see if my Windows 10 here is going to work correctly. Yep, it is. So this is the jump lists. So if you right click on this button, it shows you what you've been doing, folders you've recently been opening and such. Those things are called jump lists, and this was a big step forward. You have not only the start button, but you have all your applications that you pin here as sort of secondary start buttons to point to things that you might want to use. So that was jump lists, and that's important for user convenience and important for forensic examiners because that's yet another record of what you have been doing recently on the machine. All right, it's got backup and restore available. And Bitlocker is Microsoft's encryption system. It's very important. if you encrypt the hard drive, then even if you leave your laptop on a plane and somebody steals it, nobody can get the data on it because it's encrypted, which is the main purpose of it. Microsoft also added Bitlocker to Go to encrypt USB sticks and portable devices. And Bitlocker is considered a very good encryption system, although there are some ways to defeat it. They are very, very difficult. So encrypted stuff with Bitlocker is very secure. And if you get a forensic image of a hard drive that's been encrypted with Bitlocker and you don't have the key, that data is essentially impossible to recover. All right. You can mark USB devices with various systems to limit what USB devices are available. Yeah, touchscreen features and sticky notes, and then registry, which we've talked about. Event viewer's been around for a long time. Microsoft has an event log that records things on the system, although it's not often terribly useful for forensic purposes. It's more useful for system maintenance and repairing buggy applications. And you have web browsers, of course. And files can be viewed in these meta folders that will gather, say, pictures from all different locations. I never found that to be much use for anything, really, either for user convenience or for forensic examination, but it is a feature in modern Windows operating systems. Windows 8 was pretty mind-boggling, like Vista. This is Microsoft's pattern. They make the big changes in every other version and usually foul everything up and irritate everybody, and then the second small change is the one everybody likes, because the big changes usually don't go along with hardware, they don't have the right drivers, they don't have the right instructions, and people don't know what's going on. The small changes when they get it right. So 8 was like Vista, a sort of version that just made everybody angry, and Windows 10 is the upgrade from that got popular again, where everything seems to be working pretty well. All right, and it does have Cortana, which I haven't used, but people get used to this. Yeah, that's right, it's always this way. Good, bad, good, bad. In fact, Microsoft at one time had a plan to do all their operating systems this way, where they were going to be R2 and D2. R2 and D2 was going to be their upgrade cycle. It's kind of intentional. Anyway, if you're using the voice search Cortana, there might be interesting records there. I've never used this stuff or the Apple version. I just turn them off. But I think a lot of people do use it, especially with these smart speakers. So there might be a lot of useful information there, but I don't know much about it. All right. So that's the summary of this. And I've got another Kahoot. There it is. Mod 2B. I'm pretty backward on getting home conveniences like smart speakers and TVs and stuff, so those things are full of interesting data, I suppose, but I have no experience with them. All right. I think 11 might be, however, as many as we had last time. I'll give it a few more seconds. Okay, good. I better wait a bit. People are still coming in. All right, I think this is good enough. Okay, So where are the current desktop settings? They're an HKey current user. It can't load those until it knows who's logged in. So they're in current user. All right, so what artifact has copies of all or part of a volume? The Volume Shadow Copy Service has these automatically created backups. By the way, I forgot to mention earlier HiberFile. You can hibernate your machine instead of shutting it down, and then it takes the full contents of RAM and puts it in this thing called HiberFile. So when you open it up, it can just load the RAM back up and continue where you left off. Even programs that are not saved will appear. So that's what HiberFile is. It's a RAM image, so it might be useful, but it's not always there. Not everybody uses hibernation. Anyway. All right, so what's the hard drive encryption system? That's Bitlocker. Very powerful, very important. Apple's equivalent system is called File Vault. And, you know, for decades or more, people have been saying everyone's going to start encrypting their stuff, and that'll be the end of computer forensics. And, you know, hasn't really happened. And by the way, computer forensics, like instant response, is moving to live response, where you just take information from a running system, and encryption does nothing then. So anyway, but encryption, if everything was encrypted, then you wouldn't have the old-fashioned forensics where you just take the image of a powered-off hard drive and extract data from it. That would not really be practical anymore if everybody used Bitlocker. But they don't all use Bitlocker, not even yet. All right, so which registry hive has file name extension associations? Okay, that's HKey classes root. That's where they are. The programs associated with each file name extension. All right. Another person will have to give me the real name if they want points. S squared, I know who that is. And A will also have to tell me who they are if they want their points. All right. So, all right, I'm going to stop this recording.